Okay, this is an example of a heat loss, heat gain problem where what we are trying to do is find the final temperature of the mixture. Okay, so I'm going to give you a chance to read the problem. Okay, this problem is a minus mc delta T equals mc delta T. It's a heat lost equals a heat gained problem. So we're going to set up our lost columns and our gained columns. So what we have to figure out from reading this is which substance is going to lose the heat. And since it's the zinc that's been in boiling water, and we're going to put that zinc into another cup of cold water, it's going to be the zinc that loses heat. So in my lost column, I have my mass of zinc, that is 65 grams. I need to know my specific heat of zinc, which was given in the problem as 0.389 joules per gram degree Celsius. The initial temperature of the zinc is going to be 100 degrees Celsius, and that goes back to our 0th law of thermodynamics, since that zinc has been in the boiling water. And objects in thermal contact eventually reach the same temperature, so the initial temperature of that metal is 100, and T final is what I'm looking for. So the delta T here is T final minus 100. Now on the gain side, it's the water. So I have the mass of my water. And now here's the only real trick in this problem, and it's not meant to be tricky. You have 45 milliliters. You need to remember that milliliters equals grams for water only. So you have 45 grams of water. The specific heat of water is 4.186 joules per gram degree Celsius. The initial temperature of that water was given as 12 degrees Celsius, and the final temperature of the water is what we're looking for. So the change in temperature of the water is T final minus 12. Okay? So that's my given information. I'm going to take that given information and I'm going to substitute it into that equation. Okay? So I'm going to start with the mass of the metal, which will be minus 65. Remember, we're going to drop units here because that will just make our life a lot easier. It's then times 0.389 times T final minus 100. That is going to equal 45 times 4.186 times T final minus 12. So I've just put in all the numbers that I need to know. Okay? Now, remember what we talked about in class? The rest of this problem is just algebra. Okay, so I need to take this minus 65 times this 0.389. And when you do that, you get minus 25. And it's minus 25 point something. But at this point now, drop your decimals. And we still have the T final minus 100. We haven't done anything with that. So all we have done so far is multiplied those two numbers together. We're going to do the same thing on this side. We're going to take those two numbers and multiply them together. And when you do that, you get 188, and I believe I dropped some decimals there, but this is still times T final minus 12. Okay. Now what we need to do is distribute. Okay? So I'm going to take this 25 times TF. So that's minus 25 TF. Okay? Now I have to take the 25 times minus 100. And you got to pay attention. You have a negative sign here and a negative sign there. So you need to make sure that that becomes positive. A negative times a negative is a positive. So that's 2,500 then. That equals, now we're going to distribute on the other side. We're going to take 188 times TF. So that will be 188 TF. Okay, then we're going to take 188 times minus 12, and you need to pay attention to signs. So this is going to be minus 2,256. Okay? Now, what we're going to do is combine like terms. I have a TF term here, and I have a TF term there. I want to combine those two terms by adding 25 TF to this side, which brings that down to 0. And then I'm going to add 25 TF over here. And when you do that, that gives you 213 TF. Okay? I still have my equal sign in here. Now, your next like term is this term, which doesn't have any variable with it, and this term, which doesn't have any variable with it. So we want to combine those two, and the way we're going to do that is we are going to add 2,256 to this side, which brings that down to 0, and we're going to add 2,256 to this side, and when we do that, that gives me 4,756. Now, I'm just going to bring this down here. I have 4,756 equals 213 TF. That's what I have left. I want to solve for TF, so I'm going to divide both sides by 213 because I want the TF by itself. So the T final then for this is 22.3, and it's degrees Celsius.